All right, guys, 3.4 velocity. So this is the first section in calculus where you're going to do some sort of calculus. You're going to find derivatives or whatever it is, and that's going to help you solve some real life situations, okay? So first of all, let's say you have this formula that's for position. So they have some sort of position. Like, you know how you have, oh, this is the path that a ball takes when you know, a golf ball, when you hit it into the air. And then usually it's in sort of parabolic shape, okay? So think about that kind of formula, but now we're just talking about position in general, position of any sort of object. So displacement is basically how far it's moved. That's all it is. So from my house to your house, if it's 3 miles away, you just subtract, and that's your displacement. So you are 3 miles away from me. I am 3 miles away from you. Okay, so that's displacement. You just do position minus position. That's all it is. Okay, and then here's the more like serious part. Velocity. It's not that serious. Velocity is the first derivative of position. So you have this position formula. When you take a derivative, yes, the derivative is some sort of slope, but the derivative is also velocity for that position. If the velocity equals 0, it should make sense. If velocity equals 0, so think of velocity, a lot of times we think of it as speed, right? So like miles per hour or something. So if it was speed, if your speed in a car was 0, then you are like not moving, right? Or you're changing, maybe you're making a U-turn. If velocity is positive, so you are going 60 miles an hour, then you are moving either up or to the right. So you either go up, down, or you go right, left. So we're talking about like 2 dimensions, okay? So in our little like simple minds of calculus so far, we have a 2-dimensional plane. We have x's and y's, basically, okay? So either you go up, down, or right, left. So if your velocity is positive, you're either going up, because that's positive, or to the right, because that's positive. But now, so this isn't quite speed, so it's called velocity. Velocity can be negative. So the velocity, we never say this, but if the velocity is like negative 60 miles an hour, then you're actually moving south. You're going like south instead of north. You're going west instead of east. You know what I'm saying? So negative velocity means you're either going down or to the left. So there is a negative velocity, but realize there's no negative speed, right? So let's keep that in mind. Okay, now speed. What is speed then? Well, speed is the absolute value of velocity. When you go down a freeway, again, you don't go negative 60 miles an hour. So speed is just the positive version of velocity, so absolute value of velocity. Okay, and then it gets to acceleration. So acceleration is the second derivative of your position, or you can say it's the first derivative of your velocity. So you take derivative of the position, you get velocity. You take another derivative, and now you have acceleration. Acceleration is, so don't think of it as speed, but in your car, acceleration is how your foot pedal goes down or comes up, right? So like when you're accelerating, you're pushing your foot down onto the pedal, but when you're de-accelerating, then you're lifting your foot off the pedal, okay? So if acceleration is 0, then you're at a constant speed. Your foot is constantly at that same place on the pedal, okay? If your acceleration is positive, then your velocity is increasing, because acceleration is the derivative of velocity. So acceleration is the derivative of velocity. It's the second derivative of position. So if it's the derivative, that means that velocity, which is, you know, its original function, is increasing. So velocity would have this positive slope, which means velocity is increasing. And then when acceleration is negative, the velocity would be decreasing. So we're still thinking in terms of, you know, velocity's slope is acceleration, okay? So an object is, I like this part, speeding up. You're increasing in speed. when both velocity and acceleration are the same sign. So we say the object is getting faster and faster, speeding up when you're in a car going, let's say, north, and your foot is going like down on that pedal, right? So that makes sense. You're speeding up. An object is slowing down when your velocity and acceleration are the opposite signs. So here's an example of speeding up, same sign. Another example of speeding up would be if you're going the other direction. So you have a negative velocity and a negative acceleration. So you would still be speeding up. So if you're speeding up in the other direction, you would have the same sign. You would have a negative and a negative. Negative velocity, negative acceleration. So it makes more sense when you think about slowing down as opposite signs for velocity and acceleration. So think about going north, but then your foot is coming off the pedal slowly, right? So like acceleration is negative when your foot is coming off the pedal. So imagine that happening. Well, when your foot's coming off the pedal, but you're going north, that's going to be opposite signs. So this is positive, this is negative. So that's when your speed is decreasing. So if one of them's positive and one of them's negative, your speed is going to be decreasing. Okay, you're slowing down. Okay, so it's a little tricky, but once I do the first example, actually we're going to skip. We're not going to do example 1. We're going to do example 2. And then you're going to try to do example 1. Okay, so here's example 2. So here's what you're going to do. So this is some sort of position formula. So what you want to do is obviously find your first derivative, which is velocity, and your second derivative, which is acceleration. So I did all of that. So hopefully, makes sense. It's not crazy. So velocity, you take the derivative, and then you get this. And then I'm going to try to factor this. It's really important. You have to take the velocity and then factor. So I factor out of 6 because I can. And then I factor this part. So t minus 2, t minus 1. So at t equals 2 and 1 seconds, my velocity is 0. What does that really mean? That means I'm paused. In my car, I'm paused. So I'm either making a U-turn or I'm at rest at 1 and 2 seconds. Okay, and then from there, I have my velocity. Now I'm going to find my acceleration. So I take another derivative. I take my second derivative, I factor, and I get t equals 1.5. So at 1.5, my acceleration changes from, either positive to negative or negative to positive. But at this time, my acceleration is 0. That's what I know. Okay, so this is what I'm going to do. Always, always, always. On top of each other, I'm going to have a velocity number line and an acceleration number line. And they have to be right on top of each other so you can really tell what's going on, okay? So velocity starts at 0 because I think, all the stuff, starts at time equals 0, okay? You can't have negative time, okay? So this is 0. And then at 1 and 2 for velocity, what happens is I'm going to have to decide whether I have a positive velocity or a negative velocity. So how do I decide that? I literally plug in. So here's what I mean. Between 0 and 1 is a 0.5. So it seems crazy because there's a fraction or a decimal, but 0.5. I stick it in here. 0.5 minus 2 is negative. 0.5 minus 1 is negative. Negative times negative is positive. So 0.5 right here, I have positive. So all of this is positive velocity. I do the same thing for this little section between 1 and 2. So I plug in like 1.5. Plug in 1.5, that's a negative. Plug in 1.5, that's a positive. Negative times a positive is negative. I do the same thing over here on the right. So what I can do is I can plug in like a 10, right? Because 10 is bigger than 2. So plug in 10, positive times positive is positive. All right. My velocity is going from positive to negative to positive. That means I'm going, if this is going right and left, it's either going up, down, or right, left. If this is going right, left, I'm going to the right, I'm turning around, I'm going to the left, I'm turning around, and I'm going back to the right, and I'm going to the right forever and ever after time equals 2. And then I do kind of the same thing for acceleration. So my one acceleration change is at t equals 0.5. So at 0.5, my acceleration is 0. To the left of that, I might choose a 1. So I plug a 1 into here. 2 times 1 is 2. 2 minus 3 is negative. Negative times 6 is negative. That's why this is all negative. And then over here, I can plug in whatever I want. I can plug in a 2. I can plug in a 10, right? So 10 times 2 minus 3 is positive. Multiply, I get a positive. What this really means is my acceleration is negative, and then my acceleration is positive here. My foot is coming off the gas pedal. My foot is going on the gas pedal. Okay? And my foot is like constant right here. So it's going off, and then it's going on. Okay? So it's like, that's where it's changing from negative to positive. Basically, negative velocity slope to positive velocity slope, because this represents the velocity's slope. This represents the position's slope. So I'm going to the right, I'm going to the left, I'm going to the right, or I'm going up, I'm going down, and I'm going up, right? Okay, so to answer all those questions, these are really good questions. Okay, I'll do it 2 at a time. When am I moving to the right? Between here and here. So 0 to 1, 2 to infinity. Be careful of how you write it. I'll show you in a second. When is the velocity decreasing? Velocity is decreasing when the slope of velocity is negative. The slope of velocity is acceleration. It's negative between 0 and 1.5. Notice that these are parentheses always. So I'm moving to the right, not right here, but after the 0. And I'm not moving to the right at 1. I'm actually not moving at all at 1. So that's why these are all parentheses. Okay? Okay. When am I moving to the left? Right here. When do I have a constant speed? Do I ever have a constant velocity? No, never. Okay? When am I changing direction? Oh, I'm changing direction at time equals 1 and time equals 2. When am I speeding up? This is a good question. Speeding up is when velocity and acceleration are the same sign. So this is what you do. You look at it and you go, oh, this is why this is pink and this is blue. So I color-coded it to make it easier for myself. Different colors, I'm slowing down during this section. Same colors. Okay, between 1 and 1.5, I'm speeding up. Different colors, I'm slowing down between 1.5 and 2. Same colors, I'm speeding up between 2 and infinity. So that's where I'm speeding up. I'm speeding up between these two and between these two. So that's where I'm speeding up. Okay. And then, oops, when is the velocity increasing? The velocity is increasing when the slope of velocity is positive. That's right here. That's when the slope is positive, because acceleration is the slope of velocity. When am I slowing down? I'm slowing down, like I said, over here and over here. So final answers. Okay? You do number 1. Do number 1. Pause this right now and do number 1, and then I will show you the answers, but you need to practice because your homework is not very much today. So you really need to practice. Your quiz is coming up soon. Okay. So here's the work for number 1. So hopefully you got all of these. And then you drew your little picture. You want to color code. I swear it makes life so much easier. After you color code, here are your final answers for number 1. Final answers for number 1. Okay. And then you're going to flip to the back. And on the back, you have a picture like that. And you have a whole bunch of questions. So we're going to use the picture to help us. And then I'm going to go ahead and draw into the picture with you. Okay? So here's what you want to do. Because you want to figure out, like, you know, in the front, we figured out when is velocity positive and negative and positive. When is acceleration negative and positive. All that stuff. So for each part of this graph, and this is the graph of velocity. Okay? For each part of this graph, this little segment, this little segment, this little segment, this little segment. So there's a lot of little segments. You want to label what is the velocity, what is the acceleration. Right here, this is a velocity graph. The velocity is positive. It's above the x-axis right here. The acceleration is the slope of velocity. The acceleration is negative. So again, right here, the velocity is positive. Right here, the velocity is positive. But then here, the acceleration is positive. The slope is positive. So acceleration, positive. Acceleration here is negative. You're going to label this piece, all of those pieces. Do it. You do it. Don't just copy me. So speed through this if you want. Oops, that's an A. Velocity negative, acceleration positive, and then right here you have velocity equals 0, right? We're at 0, and acceleration equals 0, because the slope is 0, just like here the slope is 0. Okay, so check those. Answer all those questions underneath. Answer them. Pause. Answer them. Do it. And then you can check your answers here. So, when are you going forward? When are you going backward? When are you speeding up? When are you slowing down? When is the particle moving at a constant speed? Check all this. It says at rest on interval. So constant speed, and then I said, at rest instead of constant speed. Because this one, it's not a constant speed. The speed, well, it is, but the speed is 0, so it's kind of weird. So I wrote it like that, okay? When is the particle's acceleration positive, negative? So here's acceleration positive, acceleration negative. When are you changing direction? Okay. And then this is interesting. I like this question down here. When does the particle move at its greatest speed? Remember, speed is the absolute value of velocity. So what I did here is I used a highlighter and I bounced everything up to make a positive graph of speed. Right now, velocity can be positive or negative. Speed is absolute value. Speed always has to be positive. So everything just got reflected up over the x-axis. So when do you have the greatest speed? Where are you highest? You're highest right here from 2 to 5 seconds, or whatever it is. So from 2 to 5. There you go. Okay? Okay, you are doing B as well. So on the other side, you're doing B. Do it, do it, do it, do it, do it, do it, do it. Okay, answers. I love these two. This is something that we haven't done in the front, but we know how to do. You know how to plug in and subtract. You know how to find an average rate of change. The average velocity is going to be your slope, like old school slope of this. So see how it's s of 2 minus s of 1 all over 2 minus 1. So y's over x's. Okay, these two, I'm going to ask you a billion times. Okay, all the other ones too, I'm going to ask you a lot, but those two especially, I'm going to ask you a billion times. Okay, check your answers. And then, oh my gosh, do I love number 6. I love it so much. So try it first. Check your answers. And then I showed my work for both. So really, this is like part of your homework, right? So I want you to try this. I want you to be okay with this. You can ask me about it tomorrow, but there you go. Okay, good luck. You do have a few problems for homework, but it's not very much. Okay.